shakalaka. Let's take a look at some of the things that we have done since our last test. Actually, we did section 2.1 on our last test, and we're going to do it again on this test. So what does that tell you about section 2.1? That's right. It is important. So let's start with this problem that's on the right-hand side of your page there. And we're going to solve this linear equation, which means x is on one side, constants on the other. Now we've done a trillion of these, so these should hopefully be getting to be second nature. Let's see how we would proceed here. So if I distribute the 3, I'd have 3x minus 6. And distributing negative 4 would give me negative 4x minus 24. Do what? You do? How come? You just like it? Okay. And on the right side, if I combine like terms, I'll have 4x and plus 8. So let's talk to Aiden and Hannah and tell me what the left side is going to look like on the next step. Okay, negative 30. Well, you got the right idea. Yeah, just negative x. 3x minus 4x be negative x. And on the right side, we still got 4x plus 8, class. All right, you guys want to go to the left, to the right?
Both.
I'm not doing both, no. I will not do both. Okay. So she wants to go to the right. Aaliyah wants to go to the right. So we're going to add x to both sides to put our x's on the right. Those to cancel. So now we've got negative 30 equal to 5x plus 8. Then what? Okay. Subtract 8 from both sides. Get those to cancel. And we'll have negative 38 equal to 5x. And divide by 5. Class, there's nothing wrong with an answer of x is equal to negative 38/5. Nothing wrong with that at all. So that's the way I'm going to leave this one. Your question or comment? So this problem is just like that one, except we've got some fractions involved. And I'm going to rewrite this problem because I don't think I left myself much room to work there. So I'm going to spread it out a little bit more. That's the way I like to do is give myself some space. Okay, so if I wanted to clear the fractions, Cannon and Chrissy, I would multiply by what number? 5 would not clear all the fractions. It would clear some of them. What would clear all of them? 15. Let's multiply everything by 15, class.
So, when you're doing,
Okay, let's see what happens here then. 5 is going to cancel 15 and make 3. And that 3 I've got to multiply by the x minus 10. So throw some parentheses around the x minus 10. And that'll give you 3x minus 30. Hey class, what's going to happen when I take 15 times 2/5? They said 5 is going to cancel with 15 and make 3, and then you got to take the 3 times the 2 and get 6. What about over here on the right side? What are we going to get? 3 is going to cancel 15 and make, and negative x times 5 is negative 5x. Do I sense a bit of unease on this problem?
Yes.
Okay. But getting home from here shouldn't be that bad. So let's go ahead and take this problem home. So we got a negative 30 and a plus 6 we can combine and make negative 24 out of. And it probably makes some sense to put the x's on the right this time, doesn't it? Okay. So those go. So we have negative 24 equal to negative 8x. And if we divide by negative 8, we'll get x equal to positive 3. There's only one kind of problem that you're going to have out of section 2, and it's just exactly like the problem you had on your last test from section 2. I'm going to give you an equation, and you're going to be asked to solve it for a specific variable. In this case, we're solving for y. So, do you see, class, that to do that, my first maneuver would be to get rid of the 3x over here, because I'm trying to get the y by itself. Subtract 3x from both sides. And then those will cancel, and we'll have 4y is equal to, 16 minus 3x. We can't combine those because they're not like. Yes, ma'am.
Okay, so would it be wrong, if you put minus 3x plus 16?
Nope.
Okay.
It'd
Either
be
way, it's the same.
just as right as what I got.
Okay.
And now to get the y by itself, we'll divide by 4. So divide both sides by 4 here. And those 4's are going to cancel. And so how about y is equal to 16 minus 3x over 4? So we have practiced a million of these now. That's an exaggeration. We practiced a bunch of them. So you know the kind of things that are common. Things like perimeter problems, mixture problems, denomination of coin problems, motion problems. We practiced all those. So those are the kinds of things you're going to see on your test. So I have referenced us here to page 127, number 24. Which is actually on page 128, technically.
Technically. I was looking, I was like, I think this page number isn't.
I'll tell you what, you guys work ahead of me here. I'm going to read the problem. You can read along with me. And you guys see if you can get the first 2 columns of the table filled out.
Okay.
And then I'll catch up to you. So here you go. How many liters of a 20% solution of a chemical should be mixed with 15 liters of a 50% solution to get a 30% mixture? Go. Well, let's see if you got the first 2 columns filled out properly. So I always encourage you to do the percentages first. And we got a 20 that we're mixing with a 50 to get a 30. So the number below the line is between the other 2, so that's good. The second time we read the problem, we're looking for how much of each. We're looking for the amount of 20, so that's x. The problem told me that I had 15 liters of 50, so that's 15, which means we're going to end up with x plus 15 of the 30. So far, so good? Okay, so to get the amount of chemical, we're going to multiply each row. So 20% of x is 0.20x is the amount of chemical in the 20% solution. .50 times 15. That should give you 7.5. Anybody verify that for me? Okay. And then down here at the bottom, the amount of chemical will be .30 times the x plus 15 liters of solution. So if we add the first two, it should be equal to the bottom. So the equation that you need to solve this problem is 0.20x plus 7.5 is equal to 0.30 times x plus 15. Okay, now what do you guys want to do? Do you want to go ahead and finish solving this equation? Or do you want to assume that you can solve it? I can give you the answer and you can check it later and we can spend more time setting the next one up. What do you want to do? Have one vote for finish. All right, let's finish it. So I got 0.20x plus 7.5. If I multiply the 0.30, that'll give me 0.30x, and I believe if you take 0.30 times 15, I think you're going to get 4.5. I'll put my x's on the right-hand side, so I'm going to subtract 0.20x from both sides. Those go, so I have 7.5 equal to 0.30 minus 0.20 is 0.10x plus 4.5. I'm about out of room, but if we subtract 4.5 from both sides, then that's going to give me 3 on the left side is equal to 0.10x on the right hand side. See if I can get all that on the screen as much as I can. And dividing by 0.10, looks to me like x is equal to 30. Is that what you guys got? Okay, class, at this point in the proceedings, do you consider that problem easy, moderate, or hard? Okay, that was about half and half, Aaliyah, so you can take your pick. But you remember how they started? It's like, wow, that's crazy. And now they're like, I can handle those. It's not so bad. Now, I only had a couple of different application problems written down here, but I think I want to do more than that. So, let's also look at number 28 off of that same page. And this is a denominations of coins problem. And at least here we can get the problem set up. Okay, I'm going to let you guys finish this one, but we'll get it set up. So is everybody there? Number 28, here we go. When Jim emptied his pockets one evening, he found he had 19 nickels and dimes with a total value of $1.55. How many of each denomination did he have? Okay, so on denominations of coins problem, I encouraged you to start the same way we did with our mixture problems, except our denominations went down the middle. And on this problem, we have nickels and dimes, 0.05 pieces and 0.10 pieces. Over here, we're going to ask the question, how many? And I'm about out of room, so I'll just put HM with a question mark. And I don't know how many of either one. The problem did not tell me. But it told me that I had 19 total. So class, if I let one of them be x, doesn't matter which one, then how many of the other am I left with? Now I have 19 total. I used up X of those as nickels. So how many dimes? 19 minus X. There you go. So I have 19 minus X dimes left. Okay, so if we multiply the number of coins times how much each coin is worth, it's going to give me my amount of money. So X times 0.05 is 0.05X. 0.10 times 19 minus X is just what I just said. And when I add those, I should get the amount of money that I have, which is $1.55. So to solve this problem, you could solve this equation that I'm going to write down here in black. 0.05x plus 0.10 times 19 minus x is equal to $1.55. That's a 1 right there. And you guys can take it home from there a little bit later, but that's how we'd set it up. So, denomination of coins problem, class, easy, moderate, or hard?
Moderate.
Moderate, okay. What's our score so far, Aaliyah?
We got 3 for moderate. We got 3 for easy and 2 for moderate.
And how many hard?
None.
How many?
0.
0 hard problems so far. Wow. This is wonderful. Okay, now I have, okay, so for page 127, number 21, here's what it says. The length of a rectangle is 3 meters less than twice the width. The perimeter of the rectangle is 42 meters. Find the length and the width of the rectangle. If you're saying that's too much to think about, then I would say don't think about it all. Just think about what they're asking you for. And they're asking us for the length and the width. So you always start with the question. So I need something for the length, something for the width, and I'll let the variable be the one that I know less about. I don't remember which one I know less about, so I'm going to reread. So y'all tell me from this sentence, should I let the variable represent the length or the width? Here we go. The length of a rectangle is 3 meters less than twice the width. Did you say X?
I think the width should be X.
I think it should be too, or W if you prefer.
Yeah.
Because we don't know anything about W. Now if the width is W, then the length is going to be what? 3 less than twice the width. What's twice the width?
2W minus 3.
And then 3 less than that would be 2W minus 3. Come on, pen, there. Okay, now we're going to have to try to come up with an equation.
Is that 2W?
It's 2W minus 3. It's just not a very pretty one.
Okay, kind of look like it has a little dot in between.
Yeah, well, yeah, it's kind of ugly. It is. So look, if this is the width and this is the length, then it's 2W minus 3. Then that means this guy down here is also W. And this side length over here is also 2W minus 3. And if I add all 4 of those together, I should get the perimeter. So let's do that. So let's add our W's together. W and 2W is 3W, plus W is 4W, plus 2W is 6W. Negative 3 and negative 3 is minus 6. So there's your perimeter, 6W minus 6. And the problem told us that that's equal to 42. How are we doing, class? All right, so add 6. Get those to cancel. So 6W is equal to 48. And divide by 6. And W is equal to 8. So the width is 8. What's the length?
3 less.
3 less than twice that.
Oh.
So twice that would be 16. 3 less that would be 13. So the length is 13. The width is 8. These word problems are not that bad. We'll get them. We'll just keep after them until we get them. So here's a mixture problem. Opposite directions. We did several of these. 2 trains leave Ulin at the same time. One travels south at 45 miles per hour. The other travels north at 60 miles per hour. How long will it take for them to be 630 miles apart? Okay. So on all these motion problems,
Can you? Okay.
okay, so the way I usually set these up is I draw a line representing both trains. Okay, so I got one going north, I got one going south, and I just label on each one what I know. If you set it up different, that's fine. So here's what I know. I know the one traveling south is going 45. So down here, R is equal to 45. And I know the one going north is going 60. This one up here, R equals 60. And the question asks how long, so I'm looking for the time, I don't know that. So I'm going to say that they both travel T hours. And if I take their rate times their time, I get their distance. So the distance of the one headed north is 60 miles per hour times T hours. The distance of the one headed south is 45 miles per hour times T hours. And if I add those two distances together, I have to get their total distance apart, which is 630. And now it's an easy equation to solve. We got 105t equal to 630. If you divide both sides by 105, and my calculations are correct, then t should be equal to 6. So it takes 6 hours for the two trains to be 630 miles apart.
Do you have to label like hours? Yes.
I'm probably not going to cry if you don't.
Okay.
It'd be nice if you do. But I know that you know how to work it, even if you don't. I'm a little bit different on that than a lot of math teachers. Hey, Anna, how we doing? So to me, that's kind of like the first half of the chapter, the first half of the test. Solving equations, working with the formulas, word problems. Okay? That was like the first half of the chapter. Then the last half of the chapter was inequalities and absolute values. And then we ended up in chapter 3 with some of those graphs to deal with last time. So you know when you get these inequalities that I'm going to ask you to graph them and put them in interval notation as well. So let's solve this one first, and then we'll do both of those things. I mean, we've done a lot of these by now, so hopefully this is second nature to you. Let's distribute the negative 6. So negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. On the right side, our first move is to distribute that negative 3. So I have negative 2 minus 3x minus 18 plus 3x.
Did you combine
Yes, I'm going to combine like terms next. I'm just not there yet because I'm not that fast.
Okay.
Okay, so combine the like terms for me on the left. Brandy, you can work with Aaliyah and tell me what I get.
Oh, okay, never mind. Anyway, what are we doing?
Combining like terms on the left like you told me to.
I wrote it down wrong.
Well, if you look at the screen, what is the like terms going to look like on the left?
And, well, I'm reading like 2. Or -18. Negative 18.
And that'd give you what?
4 is positive, right?
Hmm?
14?
Negative.
Negative 14.
Okay. Negative 14 minus 6x is less than or equal to. Hey class, on the right side, do you see that negative 3x and 3x are going to cancel? And I'm going to get negative 20.
wouldn't,
So now we can add 14 to put our constants on the right. Get those to cancel. So we have negative 6x less than or equal to negative 6. Class, what is my answer? Good. You guys passed the test because when you divide it by negative 6, you flip the sign.
There you go.
And we end up with x greater than or equal to positive 1. And in set builder notation, technically that'd be the set x such that x is greater than or equal to 1.
So you want us to put it, you want us to have 3 answers every time when we do these problems?
Well, just read the directions and they'll tell you what you need.
Okay.
Okay, so Caitlin and Maddie, should I use a bracket or parenthesis on this problemo? Bracket, good for you, because we got greater than or equal to. And we're going to shade to the right. Shade in the arrow. And so class, wouldn't interval notation then be 1, comma, infinity?
And infinity always uses parentheses.
Thank you for knowing that. Good job. How many of those you want on the test? Easy, moderate, or hard?
Easy.
Okay, now let me ask you a question. Why didn't I do any of that sandwich or business on that problem? Because it was not absolute value. That's right. That stuff only comes in when you get the absolute values. Okay, good answer. Speaking of, we got problems with absolute values on the bottom of the page.
So are the absolute value equations the only one that you set it up twice?
Yep.
Okay.
Only when it's got absolute values. Good question and good answer to yourself. Hey, this first problem with absolute values is different than most of your homework. It's different than the problems we worked in class the other day. Aaliyah's got an idea and a thought. So tell us what you're thinking, Aaliyah.
Okay, so I don't know if I told her wrong, but I want to see. So with this one, do you have to subtract the 1 before you set it up twice?
Can you give yourself a high five, please? That is outstanding. Okay, listen to me, class. I gave you one, or I think there's 2 or 3 like this in your homework. What you want to do is get the absolute value part by itself first. Okay? Always do that first, and then it'll look like one of our 3 models that I gave you last time. So before we do anything, subtract 1 here from both sides. We'll have the absolute value of 3k minus 2 is equal to 7. And now this problem fits the model for our absolute value equation, which was a split it up problem. So do you remember this? We're going to go 3k minus 2 equal to negative 7 on our first statement, 3k minus 2 equal to positive 7 on the second statement. Now, stop. So, we'll solve both of these, we'll be done. No big deal. So add 2 here, and 3k is equal to negative 7 plus 2, that's negative 5. And divide by 3. So one solution to this equation is negative 5/3. Do you know what the other solution is yet? 3? Okay, let's see. Add 2 to both sides. Oops, those cancel. Let's get her back on track here. And so we got 3k is equal to 9. And divide 3. And k is equal to 3. Two solutions, k equals negative 5/3, k equals positive 3. Okay, again class, easy, moderate, or hard? Okay, so here's another problem with absolute values. So again, it's either going to be splitted up or sandwich. But before we do anything, we need to isolate the absolute value. Don't do anything until it's by itself. So our first move here is to add 4 to both sides. Okay, who wants this next question, class? Somebody in Anna or somebody in Olin?
Well, I just have a question. I don't want this.
Okay, what's your question?
Since it has a less than sign, is this gonna be one of the ones that have like a U in the middle or no?
If somebody gets the question I was going to ask, then that'll answer the question you're going to ask.
Okay.
Okay? So here's my question, class. It's absolute value with less than. Is this a sandwich problem, or is this a split it up problem with an or? Grayson says it's a sandwich. Do we have anybody to agree with her?
Yes.
Yep, she's right, and you are too. This is a sandwich. So we're going to sandwich with negative 3 and 3, and in the middle we're going to have negative 3x plus 4. So we're just going to solve that inequality, and we'll be done. So when I solve this, it'll be in the form that I need it to be in, Aaliyah, and I won't have to worry about upside down U's or right side up U's or anything else on this one.
Okay.
So let's subtract 4 from all 3 sides, which will make negative 7 less than negative 3x less than negative 1. What's next? Divide negative 3 and flip the signs. There you go, because we're dividing everything by a negative. So all the signs get turned around. They're going to point back the other direction. These will cancel now. So here's an answer for us. We'll have 7/3 is greater than x is greater than 1/3. So I have the set x such that that is the case. Ma'am.
Okay. So what I did, because I wasn't here, I guess that one day, you know. So what I did on my homework, I did it here, but I get the same answer basically, but so I just set it up.
Okay, so let's go to our graph. So here x is between two numbers, so we're going to shade between two numbers. The two numbers are 1/3 and 7/3. And if I think about 7/3 as a mixed number, wouldn't that be 2 and 1/3? So I need to shade from 1/3 over to 2 1/3. both with parentheses because we want to exclude the values. So we'd shade in here. So Aaliyah, did you shade between those two numbers?
Yeah.
If you did, that's a good sign.
Yeah, but I don't wanna get it wrong like on the test or something.
And so in interval notation, the first number on that interval is a third. The second number is 7/3. So be careful there. The smaller one needs to go first. And both get parentheses. So there are the three parts of the answer that I could ask you for.
This one.
Yes, sir.
Can you go back up to the beginning?
On this problem, the absolute value is already by itself.
Yeah.
So we're ready to use one of our models. And with greater than, it's an or split it up problem. So let's split it up. Our first statement is going to be 5 minus 6x. The inequality sign switches, and so does the sign on the 12. So it's going to be 5 minus 6x less than negative 12. Or 5 minus 6x, and on the second one, the sign stays the same, and so does the 12. And I realize I wrote an extra x there. There. That's what I meant to write. Yes, ma'am?
I'm sorry, I know I should ask the question.
No, you just ask away. That's what you should do.
Why do you change the sign?
Okay, so if I saw both of these, then I would subtract 5 over here. Those cancel. And I have negative 6x is less than negative 17. And divide by negative 6. Flips the sign. And x is greater than 17/6. Over here, do the same old song and dance. Subtract 5 from both sides. And negative 6x is greater than 7. And divide by negative 6, and that flips that sign the other direction. And we end up with x is less than negative 7/6. Don't forget the or. It's part of your answer. It's not the same answer without it. And so in set builder notation, we have the set x such that x is greater than 17/6 or x is less than negative 7/6. Okay. So on this graph, we're not shading between two numbers, we're shading outside of two numbers. So 17/6, how much is that, class? 17/6. 2 and 5/6, somebody said. That's right. 6 into 17 goes twice, and you have 5 left over. So here's 2 and here's 3. 2 and 5/6 would be almost a 3. So a parenthesis and shade to the right. How much is negative 7/6? Yep, it's negative 1 1/6. So just a little bit past negative 1 and shade to the left. And so we have two intervals as part of our solution here. So here's where we're going to need the union sign. So for this part over here on the left, we'll have negative infinity going to negative 7/6. For the part on the right, we'll have 17/6 going to infinity. And to include both of those intervals in our answer, we'll slip the union sign in between, and there we have it.
Does it matter if you put or you?
You want to learn to use the U. That's the mathematical symbol for it.
Okay. Are you gonna explain that?
Okay, class, the thing that we have left, the two things that we have left, would be from chapter 3. So, you could see a problem like this. It would say something like, we had last time, complete the ordered pairs. And so you would have an equation, 2x plus y equal to, I don't know, let's say 6. And then I'd give you a part of a couple of ordered pairs. Like I might give you 1 comma blank. And I might give you -3 comma blank. And so your job is going to be to find the y that goes with each x. So you had some of these in your homework, right? Okay. So to figure the first one, we put 1 in for x. So I'd have 2 times 1 plus y is equal to 6. Or 2 plus y is equal to 6. Subtract 2. And y would be equal to 4. So to complete this ordered pair, we would need the y to be 4. And then we're just going to repeat that for the other one. Okay, so for when the x is 3, I'd have 2 times -3 plus y is equal to 6. Keep talking. -6 plus y equals 6. What's next? Add 6 and get y equal to 12. So to complete that ordered pair, y would have to be 12. Easy, moderate, or hard? I love this test. Mr. Black, I love algebra. All right, good for you. Here's the last kind of problem you would see on this test. It would say something like this. Find the x and y intercepts and graph, which is also like homework problems you had due for today, ladies and gentlemen. Due for today, due for today, due for today. How to turn words into one word. Like when I go home to my daughter and I say, "What's up, Buttercup?" I'll go, "What's up, Buttercup?" And then we race and see who can say it the fastest. What's up, Buttercup? I know I'm weird. Okay, so 2x plus 3y is equal to 12 is the equation we're going to use right now. And ladies and gentlemen, do you remember how to find the x-intercept? Use the cover-up method. Put 0 in for y, which basically means you're going to cover up the y, which will give you 2x equal to 12. Dividing both sides by 2 gives Anna shouting from the rooftop that the x-intercept is 6, and they are correct. No, it's all good. Keep shouting from the rooftop. We like it here. And if you put 0 in for x, we'll cover up the x, and we'll have 3y equal to 12. And dividing by 3 will give me y equal to 4. Oh, this isn't bad. Class, how about all day and all night and twice on Sunday? I mean, these are not bad here. So we're going to cross the x-axis at 6. So we'll go out here. 1, 2, 3, 4, 5, 6. Boom shakalaka.
I like these.
We'll cross the y-axis at 4. 1, 2, 3, 4. Boom shakalaka. And we play la la la, connect the dots. And that's what's coming on your test. Class, do you feel better or worse about your test?
At least now I know I've done my homework.
Good. Good. Yes. It's part of why we do the review. Okay. So, if you know how to do everything that we just did, plus the review assignment that's at the bottom of your page, page 127, 1 through 3, 8, 11, 21, 23, 24, 37 through 42, 63, 65, 71, 72, 73, 81, 83, and 89. And the homework that was due for today from chapter 3. Make sure you know how to do that, like the 2 problems that we just did. So do you want me to hunt up a couple review problems from that, or can you refer back to your homework? What do you want me to do? You can refer back to homework? Okay, that's what you need to know for this test. Now don't consider yourself ready until you do this review assignment. Check it. And when you get it all right, check it in the back and it's fine, that's when you know you're ready. Plus, when you can work 2 or 3, 4 of your homework problems that are like these 2 problems that we just did, check those and get them right, then you're ready for your test. Questions, thoughts, feelings? Okay, I'm going to